this jumps off of the polar conics recap video. I just want to go a little bit beyond what we did. It's actually very similar to what we ended up doing in second period, but in fifth period we didn't get to this point. Beyond graphing this thing, I just showed in the other video how when you graph this thing, it looks an awful lot like an ellipse, as long as you let the computer do it carefully, or else it looks like sort of a potato, otherwise you're an egg. So it's suggestive that this might actually be an actual ellipse. How would we show that? And I just want to show how that fits in with the algebra of polar coordinates that we learned a little bit about last semester but haven't done in a while. So we instead of doing tabular and a graphical presentation, let's look at the algebra. First, let's just clear the fractions. We get 2r plus r sine theta equals 8. And here is where it really, really helps to have some familiarity with polar and polar coordinates, especially their conversion to Cartesian. These are two fundamental equations that were the heart, well, part of the half of the heart of converting between polar and Cartesian. That x is r cosine theta and y is r sine theta. The other part that's really important that we're going to need to remember is that r itself is the square root of x squared plus y squared. It's just that's just the distance formula for a point xy, distance to the origin, because that's what r is. Or in other words, sometimes it's nicer to just have it as the square. Okay, that's all we're going to need for the conversion. And the nice thing is here, is that that's r sine theta. That's exactly y. Okay, so that equation we'll be able to rewrite as 2r plus y equals 8. That's already really suggestive. It says that there's a simple relationship between the radius, that's the distance to the origin, like that's the rings of this graph, and the height on the graph. Well, the height, that's a distance from a vertical line, or from a horizontal line, basically. And then this just shifts it by a constant. So I won't go into that in detail, but it basically, you can translate that directly into the geometric definition of conics, where you relate a radius to a height, and we did that on the cool polar graph, the cool parabola graph paper before. But right now, let's just see if we can get this all in terms of x and y. Let's isolate the r. That's going to be 4 minus y over 2. And then I'm just going to square both sides, because r squared is nicer than r. 4 minus y over 2 squared. And then the reason for doing that is that r squared is just x squared plus y squared. X squared plus y squared equals, I should have just left it as a 2. That's going to be prettier. Why put in fractions when you don't have to, huh? That's going to be 4r squared then. And that's going to be, oh, I do need the parentheses. Bear with me here. Just change my mind in the middle. Okay. And so that's going to be 4x squared plus 4y squared equals 64 minus 16y plus y squared. Hey, if I collect everything on one side, that's 4x squared plus 3y squared plus 16y minus 64 equals 0. We could complete the square on that and get a shift in y. It's both squares and both plus, but unequal, so that's an ellipse, and this is going to make a shift. And guess what? That's what we saw. It's an ellipse, not a circle. Its center is certainly not at the origin. It's down here somewhere, and we could figure out the center, the foci, and everything. It turns out that the center is about down here, and this is one of the foci, and the other focus is down here. Okay, but I just wanted to give you a quick run-through of, if we go back to those basic polar Cartesian coordinate conversions, do a little bit of algebra, we do come out, amazingly enough, with honest-to-God ellipse. Now, for the one that turned out to look like a hyperbola, we can do the same thing. Here, it's going to be 2r plus 4r sine theta equals 8. And so that's going to be 2r plus 4y equals 8. Isolate the 2r so we can square it. 8 minus 4y. 4r squared equals the quantity, 8 minus 4y squared. And let's get that out of the way. We don't need to look at that. Okay. 4x squared plus 4y squared equals 64 minus, now it's 2 times 8 times 4 is 64y, and then plus 16y squared. Now when we bring it over, it's going to change a sign. It's going to be minus 12y squared plus 64y minus 64 equals 0. So this is really crucial because this number increased, this 16y squared was bigger. When we subtracted it over, it now makes different signs. So this is definitely hyperbola. Both squares, but plus and minus. And we're going to have a shift still. So the center is not going to be at the origin because of this y. So we could complete the square, get all the details out of that. But the main thing is that, yes, this is a hyperbola. All right, I think that's enough for what we need to do with that. We're not going to go too far with it.